All right. Thanks, everyone, for coming along. If you could find a seat, if you haven't already, there's still a few up the front. Welcome back to the Forge preview track for our second session of the day. We've got an awesome session now where Shorya Raj, one of the engineers from the Forge FAS team, is going to walk us through the details of the Forge Runtime, which is the environment that you're going to be spending quite a lot of time in writing code. Please, a warm round of applause for Shorya.
So yeah, as Tim's mentioned, I'm Shorya. I'm one of the engineers working on Forge, and I'm going to talk about the runtime. So broadly, my talk's going to be split into 3 sections. I'm going to talk about AWS Lambda. This is the core tech that we're using under the hood to power Forge. And then I'm going to talk about some of the features that we're providing as part of Forge through the runtime. And lastly, talk a bit more about the Atlassian-specific bits. So let's talk about Lambda. And more specifically, what is Lambda? So Lambda is an offering from AWS. It's managed compute. What this means is that as Atlassian, we don't have to worry about provisioning, we don't have to worry about scaling, and we don't have to worry about ops. It's all managed by AWS for us. This is because Lambda is a functions as a service. We just have to write the business logic, and everything else is done for us. This is great for Atlassian. Since we're running your code on our servers, it lowers the burden on us to be managing this while still giving a great experience for the developer. Now, AWS by itself ships a bunch of different environments in which to execute code. There's Python, there's Go, there's Java, but it also lets you customize what the environment looks like through the concept of runtime layers. And what Atlassian's done is actually built on top of these layers. What they let you do is essentially create a custom execution environment, so you can control what the Lambda has access to, you can control how the developer's code is being executed. And how this is done is Amazon lets you create up to 5 different layers, all of which will be composed one on top of each other, but all below the developer's code itself. Now, one thing to keep in mind is that this contributes to the same resource constraints that the developer's code is subject to. So the more you ship in these runtime layers, the more you eat into what the developer can write. Now, when you make one of these runtimes, you actually have to fulfill a contract under the hood. And this is sort of what it looks like. Now, under the hood, Lambda's actually basically running an EC2 box. And it looks something like this. You have the AWS API itself with a bunch of endpoints. You have the Lambda runtime layer, which is a Node Express web server that we're running under the hood. And then you have the runtime core layer, which is helping power some of the Atlassian-specific bits. And finally, you have the developer's code itself. Now, what happens is that the web server will continually pull the AWS API for more work. And when Atlassian determines that there needs to be a Lambda function executed, so let's say you had a Confluence page open and you wanted to render some Forge UI, it would go and dispatch that to Amazon. And Amazon would come back with an invocation payload. This then goes on down the stack, right down to the developer's code, which then executes. In this case, the developer might decide to return some UI, and it would go all the way back up the stack. Now, if that execution was successful, we'll report that to the success endpoints. And this looks like a 200 to Atlassian. If this was some Forge UI, we'd run it through the pipeline and pop a nice UI on the Confluence page. If the developer's code itself throws an error, so let's say there was an uncaught exception, it needs authentication, we'd report that to the function error endpoint, and this looks like a 4xx. So this doesn't mean anyone from Atlassian gets woken up in the middle of the night, but it does mean that this would be reported to the metrics or the logging for the developer. Now, if the runtime itself throws an error, or if there's an uncaught exception, this would be reported to the Lambda error endpoint, and this gets reported as a 5xx, and Atlassian can start looking into what's going wrong. Now, that's the runtime itself. Let's talk about some of the features that we're providing. But before we do that, let's have a conversation about what these features mean. Now, I'm an ecosystem engineer, and what this means is we're having to provide features for both customers and developers. As a customer, I want apps that are secure and isolated. If my competitor's running on Atlassian and they're using the same apps, I don't want to have that competitor seeing my apps, my data, just because that app leaks some data between tenants. And I want these apps to be seamless. As an end user, I don't really care if it's an app. What I want to see is a nice, seamless experience where I can't tell if it's Atlassian or if it's a customer. I just want a nice experience as a user. And I want these apps to be responsive. If these apps are taking tens of seconds, 20 seconds to respond, it's not a nice experience, and it doesn't really help with the seamlessness aspect either. Now, as a developer, I want a framework that's easy to use. And we've seen this with Connect, where there's a lot of steps to jump through. There's a lot of effort to go through just to get an app up and running. What we want is an API that's nice and easy to use and get started with. And we want an API that's easy to run. If I have to worry about provisioning, if I have to worry about scaling, if I have to worry about setting up servers and managing SSL, it's not a great experience for me. And lastly, I want an API that's powerful. If I can't build powerful integrations and if I can't get the job I need done, there's no point to me using this framework at all. Now, in my mind, we're actually helping empower developers to build powerful apps for our customers. And so we're building features for everyone. And one of the core features that we're working on is using isolates. Now, how many of you have used iframes with Connect? It's quite a few of you. So you all know how iframes work. Isolates have a very similar security model to iframes. They have some of the same backing tech, and they have some of the same security concerns as well, security features as well. And what we do is when you deploy your code, we'll actually go through your node modules, we'll go through your code, and we'll go right up to the point right before the code would execute. And we create a snapshot of the memory through mechanisms and isolates. And what this means is that every time we invoke this Lambda, we'll actually just recreate the isolate from that snapshot. And this is a very quick operation on the order of milliseconds. Now, what this lets us do is tenant context isolation. On each and every invocation, you have a completely fresh context. You don't have any globals that are leaking between invocations. It's all fresh and bare bones. This helps the developer avoid making mistakes of basically leaking data between tenants. Now, these isolates are also very bare bones, so we have to inject everything that goes into them. And this means we also have control over these APIs. And one of the things we've done is auth handling. Now, out of the box, we ship a basic API fetch API. This is pretty much the same as you've seen. If you wanted to fetch an XKCD comic, this is what it would look like. We all know how fetch works. But Atlassian can go a step further. One of the core, as you probably heard Mike Cheer mention yesterday, we've been adding OAuth 2 support to our APIs. And what this means is we can actually start doing things like token injection into your app. We know you need to auth against our services. We know you need to auth against third parties. We can manage this for you. So as you saw here, we had API.fetch to XKCD. But what if you wanted to make an authenticated request to the Atlassian cloud? Well, it could do something like this. And this is actually available right now. As you can see, we've got as app. And that as app basically says, please inject the credentials I need to talk to Atlassian's cloud. And we've managed this on our backend, and it's all managed for you. But what if you wanted to talk to GitHub? Well, we can manage that for you as well. Now, this is a mock API right now, but you can kind of see where we're going with this. Essentially, we, as you can see in the headers authorization, we have essentially a template string which says, get me a token for GitHub. Now, using the Forge CLI, you would set the secrets for GitHub, but the rest of the token management, the rest of that would be managed for you. We can also do auth to consent flows. Now, I personally have had a hard time implementing these without libraries. And coming back to our point of Atlassian managing all of this for you, we can actually do this. So as you saw before, these are some calls to APIs. And let's focus on that top one for a sec. Right now, I'm authenticating as an app. And I'm making a request to the Atlassian API. Now, what if I wanted to make a request as a requesting user? Well, it's as simple as request user. This would basically tell the app that, hey, I need to go through a 3LO consent flow, and the Forge runtime would go through the steps needed for this. Now, if you're returning some Forge UI, this would actually return a button to the user which says, please authenticate, and this would basically put the developer through a auth to consent flow. And all he needed to do was basically change a single line. No implementing the consent flows or managing these screens, it's all managed out of the box. Now, this brings us to our next point of context handling. Because we're invoking these apps, we know what context they're being invoked from. We know what tenants they're talking to. We have all of this information that we can provide you. And we can also have the APIs manage this automatically. So as you can see here, we have this is what a mock API might look like. For a given site, for a given user, I want to take an action. Right? We can manage the calls on the back end for you. As you see here, this was a call as a requesting user, but we had to specify the cloud ID I wanted to talk to. I had to specify the Atlassian API. It was a lot of steps that I don't necessarily care about, and it's the same steps that I take each and every time. So instead, we can change this to request confluence, and this is available today as well. This automatically selects the tenant for you, it automatically selects the API, and it's all done out of the box. This also paves the way to more cross-product context in the future. For example, if you've probably seen in certain Jira issues, you can actually have linked Bitbucket repos or branches. We have a lot of cross-product context that we're integrating into our products. And with this, we could potentially see an API where we're saying, for the given issue, for the linked Bitbucket repo, take a certain action. So you can kind of see where, in a future, where we would actually have all of these contexts managed. Now, one of the things we've been talking about is tunneling. And tunneling is basically where a request that would otherwise be made to the Atlassian cloud actually goes to your local machine. This allows for a really fast dev loop without having to actually deploy anything to Atlassian. And how this works is, if you saw before in that diagram, I was talking about the Node runtime core. We actually ship that runtime core to the Forge CLI itself. So this acts very similar to something like Docker, where we have the same execution environment in the cloud as you do locally. And what this means is you can use the same tools you're used to, such as VS Code or Chrome DevTools, to step debug through your code and figure out what's going on. So this lets you use the tools you're used to and the mechanisms you're used to while still integrating with Atlassian's cloud. Now let's talk a bit more about the Atlassian runtime itself. As we've mentioned, we have custom API support, and this is done by injecting our own APIs. Oh, sorry, this is going ahead. We have the ability to inject our own APIs. This means we can add certain magic around these APIs, but it also means we can start enforcing restrictions. And this ties into our trusted by default story, which is a very strong theme with Forge that we've been focusing on. One of the core concepts behind a Forge app is the manifest, which declares the capabilities of the apps, where it's egressing data to, and what it can and can't do. And because we're running the code, because we can introspect the code, we can actually make sure that the app is actually adhering to this. If you say you're not going to egress data, we can block network egress. And this means that the end user is informed of exactly what the app is doing. And that means as a user, you can trust that the app is behaving properly. Internally, this has meant that certain apps, if they don't declare certain capabilities, we let Atlassians internally install them without having to go for admin approval. So you can kind of see where we're going with this trust story. Because the end user is informed, they can make the decision rather than having to focus on, rely on the app to do it. It also lowers the risk of developer error. It's easy to leak tokens, it's easy to leak data, but if we're giving you the APIs to talk to Atlassian, if we're giving you the APIs to make authenticated calls, it's all managed and it's a lot harder to make these errors. We still give you the capabilities to do this, but it's about providing an easier developer experience and helping avoid some of these mistakes. It also lets us keep compute and storage within Atlassian walls. As we've mentioned, we handle authentication, but we can also help you help with storage. In future, we are talking about providing storage for Atlassian at some point in the near future. What this would mean is that the data would be kept within Atlassian walls. And this helps with stories with things like compliance. I'm pretty sure all of you are aware of GDPR and having to manage RTBF. Well, if it's within Atlassian, potentially we can delete that data for you. It's all coming back to that whole trusted by default and compliance story. Now, this isn't without limitations. One of the things that we had to deal with is the fact that these isolated environments are not the same as a Node or browser environment. They're very similar, but not quite the same. They provide the same Node.js 12 features that we know, async awaits, generators, and everything else, but they don't have access to the DOM. They don't have access to any APIs or globals that you otherwise would. So for example, there's no file system. Additionally, to provide these features, we have to add them to the runtime, but the runtime is shipping alongside the developer's code. So the more we ship, the more we eat into what you as a developer can write. What this means is that Atlassian is currently providing a minimal set. Right now, we're shipping API.fetch as a main API, and with some storage or caching capabilities in the future. It also means that Forge UI wasn't shipped as part of the runtime. It's an NPM module that you can import into your project. So what this means is if you don't need a UI, you have more space to play around with, essentially. This doesn't necessarily limit what you can write. If you have, say, a dependency that needs access to the file system, you can polyfill that in. We let you bring your own dependencies in using Webpack or Node modules. So it's not about removing that capability. It's about giving you the space to work with what you need, rather than Atlassian providing it out of the box. Now, I've had to talk to you a bit about AWS, which is what we're using under the hood to power these features. And I've talked a bit about isolation and auth handling, which are some of the core features that are helping power Forge. And I've dove a bit into how the runtime itself is working and how this all ties back into our trusted by default story. Now, if you're interested in learning more, we have the booths outside down at the end, where you can come and talk to a bunch of Forge engineers about how we built this and what capabilities we might be working on. Upstairs in Shuba 3, we have the labs running, where you can play around with Forge and Forge UI. And lastly, we have the beta coming out sometime later this year. If you've probably seen the beta QR codes around. If you scan them with the Atlassian app, you should be able to sign up for Forge later this year. Thank you.
Thank you very much, Shorya. As you can imagine, there are a few complexities to wrapping a system that's really designed for running first-party code in it like Lambda, and then allowing third-party developers, such as our ecosystem, to run code in that environment within the Atlassian cloud. So thank you very much for that awesome overview of the runtime. So I think we've got 2 or 3 minutes for some questions, if there's a couple. OK, one up the back. Here, Roberto.
Hi. One of the main benefits of this is that you can host the code and you deal with the residency and all that, right? Yeah. The challenge becomes with there are other pieces that are more difficult. Have you guys thought of, say, scheduled jobs, right? Because, I mean, a lot of stuff we do is asynchronous, right? It doesn't depend on a user action. So I have to schedule thought that I'm going to run every month, every week, every something. Have you thought of that yet?
We haven't actually implemented anything for that yet, but we were considering async tasks. So internally, we have been looking at some things like function composition. So let's say a user presses a button, and we want to kick off a job in the background. That is something that we're playing around with. And conceivably, we could have a feature where you have asynchronous jobs running every hour, every day, every month. That is something that we're looking at, but not something we've actually committed to.
Yeah, there are also smaller components such as caches, right? We need to start caching some information, so that cache, that's going to be easier. And same with queues, right? Yeah. So because something is going to queue, so I need either access to my external queue that might defeat the residency of data. The same product with caches. So you can try, I mean, you don't have to replicate the whole AWS set of tools, but I think transition, I think you might want to give us some access to the rest, to the regions, right? So at least we can try to tie to where you're hosting your region. There might be some security, but in the meantime, I mean, it could be a good way to start transition towards everything is hosted with you guys. Okay, thanks.
Cool.
It's convenient, I'll just go. You mentioned earlier about possible persistence in the future, and I'm curious a little bit about that. Obviously, you know, you can easily tack into DynamoDB, for instance, on a Lambda function. Like, what about those of us who have existing DynamoDB stores or other different stores that we want to have access to? We'll be able to provide like or build like a hybridized version of this, to where we can still access the Lambda functions provided by the platform, but be able to get to our data in the background?
Again, this is very early days. We could potentially see a future where we let you use your own DynamoDB or you use your own tools, but then your app would be flagged as egressing data out of Atlassian. So it's just about making, like, if you are egressing data, we just want to flag that to the user. I don't believe we're going to block that necessarily, but it's about just letting the user know that that's happening, and so that they're aware that the app is not keeping it within Atlassian walls. And if they're happy with that, then they're happy with that.
Cool, alrighty. I think we might be one more very quick question.
Have you thought about scalability and having multiple, you know, front end, whatever you're going to call them, virtual machines, whatever, and back end processing, you know, the equivalent of dynos, web-facing dynos, and background dynos and message queues, as was mentioned earlier?
So this comes back to the fact that we were talking about using AWS Lambda. AWS manages most of that for us. Essentially, they more or less promise infinite scaling. So let's see how far that we can take that. It's basically managed by AWS is the response there. We have had internal apps that are using a lot of Forge UI components, and we haven't seen issues yet. But we'd be playing it by ear and seeing what happens, essentially.
Awesome, thank you very much. If you have any other questions or feedback, I'd encourage you to chat to Shorya after the session or come up to the labs or go to the Forge booth. And please, everyone, do leave feedback on the sessions in the Atlassian Atlas Camp app, or Atlassian Events app, I think it might be called. There's a little feedback button down the bottom. Thank you very much again, Shorya.